first I'd like to just start out by asking us to think about some of these terms that we use when we're working in our urban environments and thinking about greening. So considering afforestation, where we're establishing a forest in an area where there was not a previous forest, and then the concept of reforestation, so reestablishing forest cover in areas where there used to be a forest. And in our cities, we often talk about restoration or reforestation, and you can make a case for that. For instance, New York City 400 years ago was a pristine forest. And so, yes, there was forest in this landscape. But today, I would argue that conditions are very, very different from those conditions that the trees of 400 years ago evolved in. And so are we really thinking about reforestation, forest restoration, or afforestation? And the reason I think this matters, and it's not really just about what we name things, but I think it influences our thinking as we embark on this journey of greening our city. And so if we're thinking about just replacing a forest, it may influence our actions, whereas my background is from rural ecosystems, and you just plant trees and they grow. And I think things are different in our cities. And so I'd like to bring this back to Ron's recontinuum and revisit it for a minute. And this is where I'd like to sort of tie together what Ron just talked about with what I'm going to focus on for the rest of our time together. When Ron and I met, he was interested in doing some work here in New York City, and specifically working on phytoremediation, as he just described. But as we talked more, I realized that there may be some applications for some of these concepts, these purposeful concepts that Ron described, and being strategic in our planting, even where we're not trying to clean up some contaminant, and that the genetic variability within a species was actually much larger than I really realized, and that maybe we could use some of these concepts to select individual varieties to help us with our greening efforts in the city, irrespective of contamination. And so thinking about this continuum, we have a situation where at some point in the past, we had a forest and we degraded it through some action, anthropogenic, by building a city. And then we're back at the bottom point where Ron described the degradation piece, and then working our way up through the recovery, rehabilitation, reclamation, and then the remediation part. And so following those same steps, but perhaps not only in the context of cleaning up some contaminant. And so start thinking about what we want to do in our cities, and actually thinking about what we're asking of our green spaces. And so we want trees to grow under these conditions that they did not evolve in. The climatic conditions are different, the chemical conditions are different, the atmospheric conditions are different, and we also want these green spaces to be sustainable and resilient. It's a big ask, I think, and so it brings us back to considering: are we really reforesting or creating something new by the way of afforestation? And I'm arguing that we're creating something new, and so that requires new thinking and new techniques. And I think that's where some of what Ron just talked about and described we can bring into our toolbox and begin to think about how to do this in our cities, and maybe make, instead of planting native species in the place where we want them to grow, perhaps we will be able to create something a little more purposeful by selecting genotypes that do best tailored to the sites that we're engaging in. And so as I was talking with Ron about maybe doing some phytoremediation work here in New York City, I was also working with some collaborators with the New York City Parks Department through the Million Trees program and in the Yale School of Forestry. And this is a picture from Cascina Park, which is in Queens, New York. And it was planted as a designed experiment. And Alex Felsen was in on the design of it, as were some colleagues from the Parks Department. And purpose was set out to discover and set up a long-term research study where we would look at which species did best on these sites, and then some species diversity mixes, for instance, 1 or 2 species per plot versus 5 or 6, and then mulching or not mulching. And as you go through these trees and begin to try and measure them, and many of you have probably been at sites like this where you see a pretty wide variety of exotic invasive species that are beginning to compete or even overtop some of the planted trees, which, by the way, were planted in this picture 4 years ago, and they were 3 to 5 years old when they were planted. And yet the exotic invasive vegetation you can see in the background on the right, the ailanthus, tree of heaven, is doing quite well as well. And then we start to look at measuring these trees and thinking about the trees that were planted at the same time. On the right, we see a Celtis occidentalis, not really doing very well. On the left, we see in the middle a basswood, which is doing extraordinarily well. And these are essentially right next to each other. And then we see on the far left a black locust, which, by the way, is a native species, and it started from seed. At the same time, the purposely planted trees were 3 to 5 years old and planted and taken care of in pots for the first part of their life, and carefully planted in the ground. The black locust started from a seed at the same time and is outperforming everybody. And so you start to think about what's going on. There's different species, different kinds of soils across the city. And so we started to design some studies to look at this. One of these studies was designed by a colleague in the New York City Parks Department, and it was designed to be a pot study or a greenhouse study, and recognizing that there were different classes of soils throughout the areas that were slated to be part of an afforestation project or reforestation project, depending on how you look at it. And so we're planting trees in these soils in these parks across the city. And so they identified several categories of soils, first being coal ash. And so we collected soils from 3 parks that had coal ash in them, and this was basically areas where people, when they were burning coal for heat, had dumped the waste from their stoves, and it had built up to quite a large degree. Urban fill is a category of soil which is quite a mixture of, it could include rebar, a little trash, some concrete, things like that. Clean fill, this is specifically brought in from construction projects to put over areas that need some additional soil or something like that, only it's not really very rich in nutrients. But it does meet the regulatory standards for being clean from a chemical standpoint. Native till is what we might find out in our rural forests. And, there are places within the city that remain essentially untouched, and so they haven't been impacted by people to a large degree because they've been protected. And so all of these soils went back to the greenhouse And then we planted several species in these soils to see how they might do. And we have a paper that we just submitted, which hopefully will be out soon. But basically, we saw some big differences between species across all the soils. So, for instance, silver maple did quite well, regardless of soil type. And then serviceberry didn't do quite as well. But we also, if we took all the species and summed up the dry leaf weight that they were producing, so an indicator of productivity for biomass production, and we see that regardless of species, that certain soils supported these species better. And so what we're illustrating is that, much like Ron was saying, there's a need for being purposeful, for thinking about what kind of soil is out there and what species might match up to it. And Ron's work shows even a finer level of detail in that even within a species, there may be certain varieties that will do better, perform better, if matched properly to the soil. And so this brings us to kind of the next part of our story, and that is we in the Forest Service are used to working in areas and in forests and on lands where the federal government owns the land. So basically, the federal employees, our agency owns the land and controls it and regulates it. And yet we move into a city, and still being with the Forest Service, we don't have this kind of regulatory oversight or control. And so that's one aspect that's really different for us. And so we really rely on partners to help us engage in our research and get things off the ground. And the other really exciting part about this is that our partners have been engaged in urban ecosystem studies or management of our urban forests for quite a long time and have a lot of empirical experience, but maybe haven't had the time to do the scientific studies. And so engaging with our partners in this way has been a really positive and fruitful area to have management help us design the research questions, as I described in the last study, to help us gain new knowledge, but also to help us figure out how best to manage our urban ecosystems and forests and restore them. And so we have the New York City Urban Field Station, for instance. We have been talking with and collaborating with Rutgers University, the New York City Parks Department, the major land management agency in the city, Fresh Hills Park, and I'll be getting to that next. But Fresh Hills is a landfill that they're converting to a park. The Yale School of Forestry and Environmental Studies, we're working with them on urban ecosystems, and in the Department of Sanitation in New York City, and many others. And what we bring to the table in the Northern Research Station, and it's illustrated very well by Ron, who's working in Rhinelander in Wisconsin primarily. I am based in New York City and Durham, New Hampshire, two other research station locations. But we have at our disposal a broad network of disciplines and accomplished scientists in this area that we can tap into. And so that's something else that we could bring to the table when we're working in some of these areas, because the fact that Ron's in Rhinelander, he really has no interest in living in New York City, but I'm here, and we can work together to do some pretty interesting work, which I will talk about next. So in Staten Island, we have Fresh Hills, and as I mentioned, this is an area that was a landfill, and it's being capped right now, and there are areas that are sort of off cap, but part of what they call the legacy landfill. In other words, these are areas that people were sort of traditionally just dumping and throwing trash before it became a formal landfill. And they stopped that practice decades ago, and the areas are still there, but not quite clean enough to use by people, but they're clean enough to begin to think about getting some trees on them and engaging in afforestation. And so this was an area of interest for us to begin to think about using some of this hybrid, if you will, techniques to create a forest in an area that's highly compromised but maybe not contaminated to the extent that Ron would use phytoremediation techniques. But to begin to think about a concept that we're calling anthropogenic succession. And by this I mean trying to create a forest in these new environments. I'm arguing many times it will need to involve some activity by people to keep it going. So in our rural forests, we will often plant trees, and you don't have to go in and do very much to them over time. I think in our cities we need to continue to maintain. We saw pictures from Casino Park where those areas have to be herbicided and exotic invasive species cut on a fairly regular basis. So if we can think about minimizing the need for going in, but maybe not making it truly sustainable in the natural forest sense. And so moving more towards that, but I think needs help. And so hence the concept of anthropogenic succession. And so at Fresh Kills, we collected genetic material from willows and poplars, the workhorse species that Ron spoke about, from Staten Island, because it is important to begin to use native genetic stock, but at the same time maybe from species that we would consider to be early successional species to plant out on these fields that are, basically reminiscent of areas that had landslides or perhaps fires in the past. And so these species are uniquely adapted to capturing a site like this. And you can see here, this is the place where we'll be installing our afforestation study. And so the New York City Parks Department has gone in for the past 2 years and herbicided and cut the exotic invasive vegetation that was there. And it's ready for planting now. And so we collected these species, and then Ron did some work on how to actually begin to propagate these and get them ready so we can use them in the selection process that's outlined on the left. And so right now we've got we ship soils from the site up to Rhinelander, Wisconsin, and Ron grew those different genotypes in that soil, and we're in the process of, we just finished harvesting them and weighing them and checking for height growth and biomass production. And we'll take the best performing genotypes and begin to plant them out into the Fresh Kills site next fall. And we've designed a study along with the Parks Department and the Fresh Kills Park folks that will begin to test some of these different afforestation techniques side by side. And so on the left you see a box that represents a plot which will include the standard palette. So this is a list of species that the Parks Department has decided could work well based upon their empirical experience with doing these projects over the years and looking at the site and saying, these are the species that we think will do well on this site and that we would like to have there when it's a mature forest. And then on the far right, we see our experimental planting palette. And this is made up of the species that we select from the selection process I just described. And we're planning on taking the 10 best willow genotypes and 10 best poplar genotypes and planting them in a series of plots. And then we have a third treatment, if you will, that is a mix. So it's the willows and poplars that we selected, interspersed with the planting palette that Parks is using. And this is meant to be a long-term research study, so we'll install or plant these plants in this format, and then we will measure them over time to see what happens. And our goal is that hopefully we will find a way that maybe these willows and poplars can grow faster and reach canopy closure quicker, which would then hopefully shade out the exotic invasive species that tend to come in and begin to overtop our young trees. If this comes to pass, then arguably we would be able to reduce the need for human intervention in the future. And then as the willows and poplars grow up, we can begin to think about maybe underplanting with more shade-tolerant trees that we would like to be in our final forest. And so this sort of fully describes the concept of anthropogenic succession, wherein hopefully we are reducing the need for human intervention, but I would argue in a situation like this, we always need to be mindful of the need for coming in and making sure that these sites are not taken over by exotic invasive species. But this will provide the basis and the framework for testing some of these theories and watching them over time so we can come up with some pretty specific recommendations, and then ultimately a process by which we could apply these same types of techniques to other sites. In other words, using soils from a new site and then picking other genotypes from that area that might perform well. So that's our overall goal for this project. And that concludes my portion of the talk. And both Ron and I would be pleased to take any questions you may have.